Hello students, so here we are with the lecture 9 of haloalkanes and haloarenes. So elimination reaction. What does the word eliminate means? Elimination means removal. So where there is a removal of groups, the reaction in which there are removal of certain groups and that leads to the formation of the unsaturated compound. It is called elimination reaction. So here we have dehydrohalogenation. What is the meaning of D here? Removal. Hydro means hydrogen and halogen means halogen. So when the hydrogen and halogen is removed and the alkene is formed, then the reaction is called dehydrohalogenation. So here you see example alkyl halide when it is reacted with alcoholic KOH and heated you get alkene plus KBr plus water. So this formation of alkene from ethyl bromide by the removal of one hydrogen and one halogen from the adjacent carbon atoms is called dehydrohalogenation. Clear? So what is the meaning of dehydrohalogenation? Removal of one hydrogen and one halogen from the adjacent carbon atoms to form alkene. And this takes place in the presence of alcoholic KOH and heat. So this is the example of a beta elimination reaction. So why it is called beta elimination? Because you see here ethyl chloride, which is alpha carbon, carbon to which halogen is attached, the functional group is attached, is called alpha carbon. And the carbon at next carbon atom adjacent to the alpha carbon is a beta carbon. So what happens here when you use alcoholic KOH? It splits into K plus and OH ion. OH is a base. OH is not a nucleophile because it is alcoholic OH and alcoholic OH is bulkier. So it is not a nucleophile, it is a base. So when this alcoholic OH ions are added, they are bulkier. So they don't go to the carbon atom to extract hydrogen, but rather they are at their place and the hydrogen atom from the less bulkier carbon, that is beta carbon, comes to OH ions and forms water. So a carbocation is created here and then halogen is given out and alkene is clear. So halogen is given out from the alpha carbon and hydrogen is removed from the beta carbon. So because hydrogen is removed from the beta carbon, the carbon next to which the carbon halogen is attached, then it is called beta elimination reaction. Clear? So why you calling this alcoholic OH base? Because it is bulkier. Earlier in the reaction of aqueous KOH, remember OH was a nucleophile while this OH is a base. So what happens here? What do we say? Removal of one hydrogen and one halogen atom from the adjacent carbon atom to give alkene is called dehydrohalogenation. So this reaction takes place in the presence of alcoholic KOH and heat. These two are important things, that alcoholic KOH and heat. So alcoholic KOH provides OH ions that are bulkier and they are called base. So when this base is reacted with alkyl halide, it eliminates hydrogen from the beta carbon, beta hydrogen, and it forms water and alkene, and here the carbocation is formed. So this halide is given out and the carbocation forms and the plus charge on the carbocation is neutralized and a double bond is created here. So you get alkene plus BH plus X minus. Clear? So this removal of hydrogen from beta carbon and halogen from alpha carbon is called beta elimination. Clear? So what is the mechanism of dehydrohalogenation of alkyl halide? Let's see here. So what we said, what is happening initially, this base, this alcoholic KOH, OH ions, they are at their place and they are calling this H beta hydrogen towards it. The beta hydrogen is a lighter one. It goes there and it forms conjugate acid of base. Clear? And this, so a carbocation is formed here. When H is removed, a carbocation is formed. So to balance this plus charge, this halide ion is given out and a double bond is created here. So this alkene is formed. Clear? So this OH ions from alcoholic KOH are called base. They are not nucleophile because they are bulkier. They don't go to the atom and form bond, but rather they call the atom towards themselves and this conjugate acid of base is formed, and this hydrogen is removed. So a carbocation is created, and to balance the positive charge on the carbocation, this bond is broken, the halide ion is given out, and a double bond is created between the two carbon atoms. As a result, alkene is formed. Here? Yes. If there are two or more non-equivalent beta hydrogen atoms in a halide, then the reaction gives a mixture of product. This is according to Saytzeff's rule. So when 2-bromobutane is taken and heated with alcoholic OH, then the possibility two products that can be formed is but1ene and but2ene. Basically, it is a dehydrohalogenation reaction, and hydrogen has to be removed and bromine has to be removed. So hydrogen, beta hydrogen is removed. So here you see there are two beta carbons and associated hydrogens. So here this is beta 1, this is beta 2, and this is alpha carbon, to which functional group is attached. Okay. So here hydrogen, if it is removed from beta 2 carbon and hydrogen and bromine are removed, then the possible product formation is what? but1ene. but1ene is formed. But if the hydrogen is removed from the beta 1 carbon, then the possibility of the product is but2ene. Basically, that product is more stable, that is having more alpha hydrogen across the double bond. So here you see, if you see here this product but2ene, if you circle the double bond, then the alpha hydrogens are what? 3 here and 3 that side. That means 6 alpha hydrogens are there. While here, if you encircle this, it carries only 2 alpha hydrogens. So which is more stable? The more stable product is what? but2ene. So the possibility of the formation will be more of but2ene, and it is known as the Saytzeff product. Clear? And the other one, minor product, is known as Hauptmann product. So here in dehydrogenation, the preferred product is that alkene which is a greater number of alkyl groups attached to the doubly bonded carbon. So this is the order of the alkenes. Okay. So Saytzeff elimination is preferred formation of more highly stabilized alkene. So stability order will be the more the substitution across the double bond, more will be the number of alpha hydrogen atoms and more will be the stability. Clear? Now, if you compare the elimination reaction and the substitution reaction, the nature of Rx, elimination reaction is preferred for 3-degree alkyl halide, prefer elimination reaction, while 1-degree alkyl halide, they prefer substitution reaction. Okay. Strength and size of nucleophile. So, bulkier electron-rich species prefers base by abstracting proton, favors elimination, while substitution is favored with the weaker base. Clear? Then reaction condition. Less polar solvent, high temperature favors elimination reaction, while low temperature and polar solvent favors substitution reaction. Reaction with the active metals. So active metals like sodium, magnesium, cadmium, they readily combine with alkyl, chloride, bromide or iodide, and they form compounds which contain carbon metal bond. So these are known as organometallic compounds. For example, here you see reaction with magnesium. So alkyl halide reacts with magnesium in the presence of dry ether and it forms alkyl magnesium halide. Alkyl contains carbon and magnesium. So carbon magnesium bond is the bond due to which this is known as organometallic compound. Okay, so this is very reactive. There's the bond between metal and carbon is a polar bond, and this R contains delta negative charge and magnesium contains delta positive charge. So this is the example of a carb anion. Okay. So when ethyl iodide is reacted with magnesium in the presence of dry ether, you get ethyl magnesium iodide. Now because alkyl halide when treated with magnesium and dry ether as solvent, it gives alkyl magnesium halide, which is also known as Grignard reagent. Why it is known as Grignard reagent? Because this is discovered by the scientist Grignard. Okay, clear? Grignard reagent is a very reactive compound. They react with water and compounds containing hydrogen attached to the electronegative element. So here you see Grignard reagent reacts with water, and this, as I told you, R carries a negative charge, delta negative charge, magnesium carries a delta positive charge. So this attacks the positive part. So this alkyl group attacks H and it forms hydrocarbon, and magnesium hydroxy magnesium halide is formed. When a Grignard reagent is treated with methyl alcohol, again it extracts the H, it attacks the H towards itself and hydrocarbon is formed, and magnesium halide also gets bonded with OCH3. So methoxy magnesium halide is formed. When alkyl magnesium halide Grignard reagent is reacted with ammonia, again it forms hydrocarbon and amino magnesium halide is formed. Here. So instead of RMGX, if I take ethyl magnesium iodide reacted with methyl alcohol, then ethane is formed along with methoxy magnesium halide. Then if I take ethyl magnesium halide iodide reacted with ammonia, then ethane is formed along with amino magnesium halide. Clear? Okay. Now let's see the next reaction, Wurtz reaction. In Wurtz reaction, what happens? Alkyl halide is treated with metal like sodium in the presence of dry ether. Then what happens? The two R's or the different alkyl halides, they react and higher alkane is formed, and sodium reacts with the halide part and forms sodium halide. So basically in this reaction, higher alkane is formed. So when ethyl bromide reacts with sodium in the presence of dry ether, then what happens? The two alkyls, they form bond with each other and the butane is formed. N-butane is formed along with sodium bromide. Clear? Then if I take one molecule of methyl bromide and one molecule of ethyl bromide, that means if I take a mixture of ethyl bromide and methyl bromide and react it with sodium in the presence of dry ether, then methyl bromide will first form ethane, ethyl bromide will form N-butane, and then you get propane. So if you go to prepare the alkane having odd number of carbon atoms, you have to take the mixture of the alkyl halides and you will not get a pure alkane by this method. Clear? Okay. So the above method is not useful to prepare alkanes from alkyl halides containing odd number of carbon atoms, because in case of mixture of alkanes, if obtained. Okay, then isomerization reaction. Here you see you've converted 1 chloropropane to 2 chloropropane using anhydrous aluminum chloride. Clear? So 1 chloropropane is converted to 2 chloropropane by using anhydrous aluminum chloride, and this is called isomerization reaction. Okay, so this is all about the reactions of haloalkanes. Thank you.